Let's solve LeetCode 125 valid palindrome. A phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, we want to return true if it is a palindrome or false otherwise. So let's take a look at an example. So the S is the input given to us and it's a string, a man, a plan, a canal, Panama. The output is true. Why? That's because if we see the front thing and the back thing is the same. If you read this frontwards or backwards, it's going to read out the same. But of course, you need to remove all of the spaces, punctuation marks, anything else, colons, all of those things. And you also need to convert the uppercase characters into lowercase characters. We essentially want to remove all non-alphanumeric characters. Non-alphanumeric characters means alphabets, numbers. We need to remove all non-alphanumeric. So not alphabets, not numerical. And yeah, that's spaces, commas, colons, punctuation marks, whatever else will come our way. And we also need to be case insensitive. That means a capital case A is equal to a small case a. This is what we want to solve. Now, how are we going to solve this? A very simple solution for this is that let's say we have a string S. Okay. What we can do is reverse this string. So what I can do is have the same string but reversed this time. So I'll have something like this. I'll have A, then M, then A, then N, then A, then P, colon, L, A, N, A, C. So all I'm doing is that I'm going backwards like this. And that will give me a certain string. Then I can also convert this normal string and remove all of the punctuation marks like, spaces, commas, etc. I can remove everything and spell it out. So I'll have A like this. Also, at the end, I'll just lowercase everything. So I just have this. And yeah, that will give me essentially the same thing. Also, by the way, we don't need colon here. Colon needs to be removed. But yeah, this is what we can do. Another solution is first converting this string into this string. So we just remove all of the punctuation marks, lowercase everything, then reverse this and we get our answer. The time complexity for that would be O of n and the space complexity would be O of n as well because we try to create a string. So for that, we are going to have a list which will be joined later on. We won't do string concatenation because that would be O of n square. But either ways, we're not taking that solution. The solution we're going to take is an approach that can give us a time complexity of O of n by 2, which is equivalent to O of n. So even if you do the reverse, it won't really matter that much because it's the same time complexity at the end of the day. But this one is definitely more, you can say, better because it's more efficient. It's n by 2. So yeah, how are we going to solve this? My solution is that we have 2 pointers, one at the beginning and one at the end. So there's going to be a left-hand side pointer and there's going to be a right-hand side pointer. The left-hand side pointer keeps track of the left-hand side part. So what we're trying to do is compare the two strings, okay? Essentially 2 characters. So I'll compare the string at left. So I'll do S at L, which is equal to S at R. This is what I want to do. And I want to keep doing it for the entire string as long as L is less than R. While L less than R, because let's say we reach over here, L and R are over here. After that, what we're doing is, well, R will go over here and L will come over here. And if they go beyond each other, that doesn't make any sense. We've already compared all the strings up to here, right? All the strings up to here. If we go beyond that, what are we even comparing? We'll be comparing different things now, because then we'll be comparing n, which is s at r, and then a, which would be s at l, right? And we don't want to do that. So we'll just keep going until l is less than r, and we'll check each string. But there are a few things to keep in mind here. It's not as simple as it looks. Just doing like looping through and just incrementing L and R in every iteration is not enough. That's because we need to emit out the spaces that are present, the commas that are present, and the colons that are present. We also want to convert it into lowercase. That's not a very big thing. It's very simple actually. Just call dot lower and the string gets converted into a lowercase character. But either ways, we have to keep this in mind. So we'll keep going as long as L is less than R, correct? And then what we're going to check is that S at L, if it's not equal to the S at R. As soon as we find one character that is not equal to the other character on the right, we'll just return false. Now you might be asking, why are we comparing these two end things? How do we even get the intuition of doing this? And the answer is quite simple. What is a palindrome? A palindrome is just a string which reads the same frontwards and backwards. So that means the last character should be the same as the first character, correct? That's exactly what we're doing. As soon as we have a successful match, let's say S at L is equal to S at R. Cool. So we are not returning false. We go to the next iteration. After that, what happens is that the L pointer moves from this particular position, correct? It is no longer pointing at A. We'll increment and we'll put it over here. And for R, the same thing will happen, but now it won't increment. Because if we increment, it will go out of bounds. What we'll do is decrement. So R points towards M and L points towards a space. And this is where one of our logic places is going to come in. We are comparing a space with M, and that's not correct. We have to ignore all non-alphanumeric characters. Non-alphanumeric character is a space. So we need to skip it. So what we'll do is only increment the left-hand side pointer. We'll tell L to move by 1 and R won't move by 1. After that, we'll compare both of these things. And then we'll check, yeah, S at L is equal to S at R. So we move both of them. Cool. And the same thing will keep on going. And then we finally reach here. This will also reach here, this particular place. And then we compare again. After that, we reach a comma and A. Again, the left-hand side pointer is going to move, but this time it has to move 2 spaces, correct? Because after a comma, we have a space. Both comma and space both are non-alphanumeric characters. So we need to skip 2 of them and then move to A. So that's one condition again we have to check. Instead of putting an if condition that, hey, if S at L is not equal to S at R, or if S at L is not a non-alphanumeric character, we're going to move ahead. We can't use an if condition. We have to use a while loop. So as long as we're not at an alphanumeric character, we'll increment the left pointer, and we'll have to do the same check for right hand side, because it can be the case that we reach a condition that looks like this, correct? R points at P and L points at P as well. This is the condition we've brought ourselves to. Let me see if I can move this quickly. And I can't. I can. Cool. So now we are checking this. Yeah, P makes sense. So what we do is move the left hand side pointer by 1, and we also move the right hand side pointer by 1. But after we move the right hand side pointer by 1, what we get is space. R is pointing to a space and L is pointing to L. We can't allow that. Even the right needs to move forward. And again, if you just move by 1, we'll point towards a colon. We don't want to point towards a colon. We want to point towards L. And that's when we'll have to figure out the same thing that we did for L, moving ahead using a while loop, we'll have to figure that out for R, where it needs to move backwards. So this is going to be our entire solution, and as long as L is less than R, this thing is going to keep running. As soon as we break that condition, the entire thing gets over. Cool. So now let's go ahead and initialize two things. The first one is going to be a left pointer, which is equal to 0, and then a right pointer, which is equal to the length of the string minus 1. The left pointer is this particular thing. It's the start of the string, correct? Initially when I started, it was over here. Right is length of string minus 1 because indexing starts from 0. We want to go from 0 to length of string minus 1. We can't do length of string because length of string is out of bounds. When we try to access s at right pointer, what is going to happen is out of bounds. What we have to do is s at right pointer minus 1. So we're just instantiating this to minus 1. After that, we can just check while left pointer is less than the right pointer. In that case, we'll keep going. And now what I want to check is, well, are the strings equal? So I want to extract the characters. So first I'll check if the string at left pointer, if it's not equal to the string at the right pointer, in that case, I want to return false. But also I want to lower everything because over here we have capital A, here we have small a, and we say that after converting all uppercase into lowercase, so we'll obey the question. Even if you compare the uppercase, it won't matter. But either ways, let's just do what the question is asking us to do. Cool. If this is the case, we are going to return false. So that is a false condition. Now, once that happens, let's say the strings are equal. In that case, we're going to do left pointer plus equals 1 and right pointer minus equals 1, correct? Because for the right pointer, we need to decrement continuously. And for left, we keep increasing. That's the 2-pointer approach. Cool. So this only occurs if the string at left pointer is equal to string at right pointer. Now, this does the equal and moving of the things, but this approach just assumes that there are no alphanumeric characters, but we do have non-alphanumeric characters. So we need to include that condition, and to solve for that, we're going to have a while loop here. The while loop is basically going to check if this particular thing that we're checking for is non-alphanumeric. So while the character that we are on is non-alphanumeric, then we'll just do left pointer plus equals 1. And then we need to do the same thing for the right pointer. So while the right pointer is a non-alphanumeric character, we'll keep doing right pointer plus equals 1. Correct? I told you for both of them, we are going to require while loops, and also both of them should be executed, because it can be the case that, let's say, the left pointer is somewhere over here, so it's at a space, and right pointer is also at a space. We don't want to compare the spaces in any case. So both the while loops need to be executed. It's not an if-else case. It's an if case. What I mean by that is, like, this is not an if-else case. So if the left pointer is there, we'll just increment left pointer. Otherwise right pointer, no. It can be the case that the left pointer is at a space and the right pointer is also at a space. So we want to avoid both of them. And since we need to execute this if condition continuously, we're using while loop. Cool. Also, right pointer should be minus equals 1, not plus equals 1. Right pointer will always decrement. Remember that in the 2-pointer approach, by the way. So how do we find out that it's a non-alphanumeric character? For that, we can make use of ASCII. If you remember, in one of the questions that we did earlier, it was in the arrays and hashing topic. In one of these questions, I don't remember which one, we used ASCII to figure out, oh, I think it was group anagrams, by the way. So here we figure out what elements are going to be, grouped together by their like we created tuples, right? And then the tuple has a particular index. How do we figure out the index? Using ASCII. So ASCII will let us know if the character that we have is a valid uppercase character or a lowercase character. So what we can do is check here. So first we'll check for alphanumeric character and then we'll just do a not on that. All right. So let's check if it's an alphanumeric character. So we'll have while odd of A. Remember, this is how we did the ASCII. So while odd of A is less than the odd of the character at S at left pointer is less than odd of Z. That means we are in the range of all the lowercase letters. We can do this because odd of A I think is 97 and odd of Z. That means the ASCII of A is 97 and ASCII of Z is probably 122 if I'm not wrong. So we're just checking that. And it can also be A or it can be Z. So we have to do while odd of A is less than equal to this is less than equal to Z. So this tells us that a character is a lowercase English letter. Or then we can check the odd of capital A is less than or equal to the odd of S at left pointer is less than equal to the odd of capital Z. So this I think is 65 and then you can add 25 to it. So I think it's about 90. So 65 to 90, you just check if the character is within that range. And if it is, it's good. Otherwise, it's not. And if it's not, then we want to increase it. So now we'll wrap everything with a not. So this gives us the condition that, hey, if this is not the case or this is not the case, then we'll just increment the left pointer. And now we'll do the same thing, but for the right pointer. So let me just copy paste it and I'll remove this particular line and replace this left pointer with right pointer and then do the same thing, because essentially for the right pointer also we need to check the same thing, right? If it is not an alphanumeric character. So if you want, by the way, you can make it clean code. You can remove this out, extract this out, create a new function of its own, which just returns this. And you can name it is alphanumeric. Okay. And then you can call the function while not is alphanumeric. That would be clean code. I'm sure your interviewer would be quite impressed actually. So yeah. We can just do right pointer minus equals 1 if this is the case. We're checking for the same condition, but with right pointer within this. Okay, that looks great. Now, one thing I'd like to tell is we are using ASCII here, and this approach works because ASCII for English characters is continuous. So that means A is 65, B is 66, C is 67, D is 68. And by the way, we have to capital A and capital Z this. I don't know why I didn't do that. But yeah. So the reason this works out is because it's continuous. This is 65. So let's say your character was capital Z or let's say capital D. It will lie within this particular range, correct? And actually, I didn't have to change that. I'm tripping, I guess. But yeah, you didn't have to change that at all. We are checking the lowercase characters here and then the uppercase. That's exactly how it's supposed to be. Because, the condition is going to remain the same in left and right pointer. Only the effect is going to change here. And also this needs to change. So yeah. Either ways, not to confuse you any further, I hope you've understood this. What we're doing is skipping non-alphanumeric characters from the left pointer, skipping non-alphanumeric characters from the right pointer, comparing them, and just decrementing. Now let's say this entire while loop gets over. By the way, there's a edge case missing here. I'll get to it. But let's say we return false from here. But what if this entire loop gets over? That means right pointer is less than the left pointer. So that means right pointer went somewhere over here and left pointer went somewhere over here. In that case, the string is over and we did not return false till now. That means the function is a palindrome. So we are just going to return true here. Cool. Now if you run it, it might work for this test case. Let's see. But it might not work for future edge cases. So try submitting and you'll see that your code fails, and that's because we have to put additional checks here. We're within a while loop. It can be the case that when we put the left pointer ahead, when we push the left pointer to go ahead 3 or 4 times or even 2 times more, what will happen is that right pointer will exceed left pointer. As soon as that happens, we don't want to increment the left pointer anymore. So there's 2 conditions that we need to check. We need to check while left pointer is less than right pointer, and this is not the case. The same thing goes over here. While left pointer is not less than right pointer, and this is not the case, then we'll increment and decrement respectively. The reason we need to do that is because if left pointer exceeds right pointer, we'll start comparing nonsense. We don't want to compare nonsense. So as soon as we hit this condition, we'll just check and then we'll exit out. So let's rerun. This test case is going to run again, but let's submit this one and hopefully everything works out. Actually, it doesn't. I've run into an error. The error is that if the string is 0p, the output is true, but expected value is false. Why are we getting this error? The reason we get this error is because we have digits here, and we've not handled digits, by the way. We've only handled strings, and that's it. English characters. We have not handled numeric. We have to ignore all non-alphanumeric characters. What I've done is just done alphabets. What about numerical? So let's go ahead and add support for numerical. So what we can do is within this condition, we can also check or the odd is in 0 less than equal to odd of s at right pointer is less than equal to odd of 9. Cool. And then I'll take this, paste it here as well. And yeah, here we are going to have left pointer. Let's run this code. It works out, but let's use this test case, the test case that failed, and then try it again. So let's run that. And it works. So earlier it didn't work out. The reason for that is we did not handle digits. So what it did is skip this 0. It just thought that there's p over here, and p is a palindrome of itself. A string is a palindrome of itself. If you look at this one as well, an empty string is a palindrome of itself. So yeah, a single character is always going to be a palindrome of itself. That's why. So now we've handled the digits as well. It might look a lot messy, so just extract this in your own function and it will look like a lot cleaner. But now if you submit it, it's going to work out. Now let's say I'll demonstrate to you what happens if left pointer is not put in. So this condition is not put in. What will happen then? Let's submit it. And as you can see, string index out of range. The index out of range error exists because left pointer is no longer less than right pointer. And that causes issues because we are trying to access S at left pointer. It can be the case that the index no longer exists in the string. We've gone beyond the range of the string. That's not what we want. So yeah, let's submit it again. What is the time complexity of this? The time complexity of this is going to be O of n by 2 because we are essentially going to the middle of the string from both the sides, and n by 2 is just O of n. And the memory complexity of this is going to be, well, what do you think? The memory complexity is going to be O of 1. That's because we are just using a left pointer and a right pointer. In the previous approach, the approach where we reverse the string and stuff, the memory we use is O of n. But here the memory we'll be using is just O of 1. So it is efficient more in terms of memory. So that's a thing to keep in mind.